we're learning about different segments and different parts of circles. Some of these words we already know. So some of this will just be a quick review, okay? There is kind of a difference, though, between what we're learning about some of these words that we've already learned today and what we've learned in the past. In the past few days, we learned about radius and diameter as being a length that we use in a formula, right? Today we're actually going to talk about them as being objects. Instead of thinking of them as a length, we're going to think of them as an object or a thing that's in our circle, okay? So normally we've defined the radius of a circle as the distance from the center to the circle. But this time, instead of calling it a distance from the center to the circle, we're just going to call it a segment. Segment from the center to the circle. Okay, so for example, that's a radius right there, right? So also, instead of calling a diameter a distance across the circle at the center, at the widest point, we're just going to call a diameter this time. Today we're going to refer to a diameter as a segment across the circle through the center. Okay, so if we have a segment that goes all the way across instead of just halfway, that's a diameter, right? I'm kind of doing things in different colors. I should have actually written my description maybe in the same color blue here so that they would have matched up. Okay, and then I'm going to label them just so I can remember. This is radius. This one's a diameter. So we don't care so much about their actual lengths as we do about what they are in the picture. Okay, an arc, we learned about what that is a couple of days ago. An arc is a piece of the circumference, right? A piece of the circumference. So let's do our arc in this light blue here. So I'm going to choose an arc. Here's an arc that's a piece of a circumference. Maybe I should label some of these things with letters. Let's say that this is point A and this is point B over here. So what can I call that arc that I just highlighted? AB, but I put a little line over the top of it. And that's because it's a short arc. It's a minor arc, right? And we learned about that the other day, minor arcs and major arcs. A minor arc we label with 2 letters, and it's less than half of the circle. And then a major arc, or a semicircle, we label with 3 letters, and it goes, a major arc goes more than halfway. Should we do an example of a major arc? Or do you remember that from our notes a few days ago? Remember, okay? All right. The next thing I want to talk about is called a sector, and we've talked about that before as well. A sector is like a slice of the area, right? So I'm just going to fill in a little piece. That made my red pen kind of go weird. Okay, so this thing here is a sector. And this little thing here is an arc. And a sector is a piece of the area. The last thing that we already know that we're just going to review on this circle is a central angle. So this angle right here is a central angle. A central angle always has its vertex at the center of the circle. Vertex at the center of the circle. So those are just some different words to be aware of that we've learned before that we just needed to review, make sure we remembered what they meant. Yeah, I'm worried about you forgetting minor arc and major arc a little bit, although you don't have to remember those exact words. But this, remember, so don't forget, minor arc is less than 180, major arc is bigger than 180, and you have to use 3 letters to name it, right? Maybe I really am going to make just a note about a major arc really fast. So if we wanted to do a minor arc, that would be like the one we just did from A to B because it's small. But a major arc, we could go, let's put another point over here somewhere called C. A major arc could be through point C. How would that be different than the minor arc? What's the difference? The minor arc I've highlighted in blue, and it's just directly from A to B, the short direction. But a major arc would go from A to B through C. So it would be the large arc from A to B, right? So just if you're not sure you'll remember that it's 3 letters, that wouldn't be a bad idea. The other thing to remember is that an arc and a central angle are the same measurement, right? Vertex at the center of the circle, and the measurement is the same as the arc. So in other words, if this angle here is 90 degrees, what's the measurement of the arc going to be? They would both be the same, wouldn't they? If that's 90 degrees, wouldn't this one also be 90 degrees, right? They're the same. Okay, so this is all review. We've learned this before, more or less. Just solidifying it. Okay, now we go to new information. Okay, an inscribed angle. It does say to use a ruler. I know you have protractors you can use in your little packets if you want to be more careful with these. An inscribed angle. Whoa, using a ruler didn't help me right there. I went out of the line. Okay. An inscribed angle has its vertex on the circle instead of at the center. So here's an example of an inscribed angle. I messed up as I was drawing it. I'm going to go ahead and put letters on this inscribed angle so I can name it. Let's call it D, E, F. So I could call this inscribed angle, so an example of our inscribed angle would be angle D, E, F. Remember when you're naming an angle with 3 letters, that the middle letter is always the vertex. So the reason I put E in the middle, very important, that's where the corner of my angle is. That's going to be really important on your assignment today because sometimes all 3 of these lines will be connected, and you can only tell which angle you're talking about by knowing which letter's in the middle. Okay, the next word we're going to talk about is a chord. Believe it or not, we actually have 2 chords in our picture already. Guess what a chord is? A chord is simply a segment from one side of the circle to the other and the important thing is that it's not a diameter. It does not go through the center. Not through the center. So we have 2 chords in our picture here. There's a chord at DE and there's a chord at EF, right? I'll just highlight one of them. I'm going to use the other one for something else in a minute. So we have a chord DE. If you want, you can name it as well as defining it. I kind of have run out of room here. Or you can write a little word next to it that says chord, right? In here you could say this is an inscribed angle if you want to actually label it. Okay, two more things to talk about. A secant. A secant is a segment, ray, or line that goes through the circle. And past the edge of it. So it'll actually go all the way through. It doesn't start and end at the circle. Okay? It's going to pass all the way through the circle and maybe be outside of the circle. A segment, ray, or line that goes through the circle to the outside. It doesn't have to go outside on both ends. It could just be on one side of it. Okay? So I'm actually going to turn this piece of our inscribed angle into a secant with a ray that's going outside of the circle. So I'm going to name another point out here. I'm going to call it G. So FG, ray FG, is a secant because it actually goes outside of the circle. Now what if I just talk about from E to F? What if I do a segment and I just say EF? Is that a secant or a chord? I'm just going to write a little note over here. EF with the segment over the top. Notice how my segment has no arrows? So it starts on the circle and it ends on the circle. That is actually a chord. So what is it that makes FG, which is kind of in the same place, why is that a secant? Because it goes outside of the circle. Okay, one more word to learn. The last one we're going to do is called a tangent line. And a tangent, so this is different than the tangent we learned about when we did sine, cosine, and tangent. They're actually somewhat related, but we're not going to worry about learning about the relationship. We're just going to know there's two different things called tangent. There's opposite over adjacent when you're solving triangles. And then there's a tangent line, okay? A tangent line is a segment, ray, or line outside the circle that touches the circle at one point. A segment, ray, or line outside of the circle that touches the circle at one point. So I need to draw an entirely different line to be a tangent. I could do a whole new point and just put it over here out of the way. I think I'm going to go off of a point that's already there. Point F is right on the edge of the circle. So if I'm drawing a tangent line, it's going to be outside the circle, just touching at point F. Maybe I'll even label another point on it so I can name it. So I'm going to call that point H. So an example of a tangent would be either segment FH or ray FH. Oh, actually I just made that into a line because I put arrows on both ends. Or ray was the one I was going to do, FH. So I don't know if you guys remember this from clear back in August and September of last year, but we learned about segments, rays, and lines. A segment starts and ends. And so we don't put arrows over the top of it when we name it. So that would just be from point F to point H and stop there. But is that a tangent? Yeah, because it's outside of the circle and it touches the circle at one point F. Line FH follows the arrows forever. A line goes forever. Line FH is a tangent because it just touches the circle at this one point. Or what if we just called it ray FH? Ray FH would mean that it starts at F and goes toward H forever, but that's still a tangent because it still just touches the circle at point F. Do you guys understand how a tangent can be any of those three things and how to label them? I don't know if you remember that clear back from the beginning of the year when we learned about points, lines, and planes, and rays, and that type of stuff. Okay? Any question on what these three words mean? So we have an inscribed angle that's made with two chords. We have a chord that just, it goes from one side of the circle to the other, but not through the center, because that would be a diameter. We have a secant that goes outside of the circle, and we have a tangent that just touches the outside of the circle at one point, point F. Well, it doesn't have to be point F, it could be any one point, it doesn't matter. Okay? Does anyone have any issues with the vocabulary? Do we understand the vocabulary okay? All right, now we need to learn some properties about these things that we just talked about.